All right. You guys remember the Pythagorean theorem, I'm sure, right? What is it? Yes, that's it. A squared plus b squared equals c squared. And do you know when you use it? Which kind?
I saw.
Pythagorean theorem is only used for right triangles. Okay, that's kind of a really big deal. And here's what it states. The sum of the squares of the legs of a right triangle are equal to the square of the hypotenuse. You can cross off this that says like theorems. That was actually up above, so that doesn't belong there. I'm just going to redraw this diagram here so it's a little bit easier to see. So every right triangle obviously has a right angle. The side that's across from that right angle is the one that we refer to as the hypotenuse. And in the Pythagorean theorem, we always put it in for which of these three values, A, B, or C? C, yes, the hypotenuse is always C. The legs are A and B. They're basically interchangeable. It doesn't matter which one you call A, it doesn't matter which one you call B, but the hypotenuse has to be C. So this one could be A or B, same thing down here. But C absolutely has to be the hypotenuse. If you get that part wrong, it's kind of a big deal. So the claim is that if you take any right triangle, literally any right triangle in the whole universe, if you take the length of this leg, square it, take the length of this leg and square it, it will always be equal to whatever the length of the hypotenuse is squared. But how do we know that that's true? How do we know for a fact? We have to be able to prove it. I have one way to prove it. It's actually kind of super fun. So could you please come on up and grab one of these sheets of paper and a pair of scissors? Do I have enough scissors? I'm running low. Okay, so let me explain what you have in front of you. Everybody got a paper, right? Come on up, get a paper. I got a couple pairs of scissors left. All right, so this is so cool. Let's take a look at this diagram sort of down at the bottom. I guess we can look at it doesn't really matter, whatever, they're kind of the same. So the claim is, let's see what they've done. They have a right triangle here. One leg they're calling A, the other one B, and then we have the hypotenuse C. So what they have done is they have created a square of length that has a side length equal to A. they've created a second square that has a side length, a length of b. So here's your challenge. I want you to cut out this gray square, and then this gray square, but you are also going to cut on those lines there. I want you to fit all of these gray things in that box. Oh, it's kind of fun. Go ahead, try it. So cut out your b squared box. Try and cut as accurately as you can. Cut it completely. You're going to cut out the b squared. We are literally going to try and physically show that a squared, so the square of side length a, plus the square of side length b really does equal the square of side length c. I am a little nervous. Yeah. Again, try and cut as accurately as possible. When you cut out that a squared, you are going to go ahead and cut along those two diagonals. So a squared ends up being 4 smaller pieces. If you want, you don't have to cut out c squared, but you can. So you're going to have 5 pieces. Oh, golly. Here they are. So your goal is to now rearrange them so that they fit into that c squared box. Oh, and they also can't overlap. I guess I should have said that. No overlapping. You want it to fit in. No overlapping. It should fill c squared completely. That's up to you. You don't have to. If you get it, don't show anybody.
And I got you.
After I made 5 mistakes and I actually figured it out.
I literally said, yeah, it's like I did it.
I promise it is possible. I will give you another hint also, keep it all on the same side, so you're not gonna have any flipped over or anything.
Wait, so they have to fill up this whole? No. Or just the square?
Just the square.
Use the square. There's no way that's. Yeah, I did.
I'm gonna give you another minute or two. Get it in if you can.
Use the square. I didn't know I had this. I think I figured it out.
I thought the square.
Got it.
See, do you know when our next advisory is?
That's a great question. I don't
Oh my
know.
God, I did it.
Sorry. Okay, I'm going to show you the solution. If you want to keep trying it on your own and you don't want to be spoiled by the answer, then just don't look. Let me get mine. There we go. So there is. Oh wait. Don't look if you don't want to see the answer. So I like this because you can literally physically see how a squared plus b squared can be rearranged in such a way to fit exactly inside c squared. I'll show you a really cool video in once we're done with this. It's only like a minute long, but I don't know who it was, someone made it at like a science fair using water. They use what you'll see. It's so cool. They use water to prove Pythagorean theorem. But anyway, so yes, Pythagorean theorem really does work for any right triangle. Okay, so where did my pencil go? There it is.
Not like that.
I got it. Okay, so as I already said, you can use it to find, are you listening? Any side of a right triangle if you have the other two. So let me give you an example and then I'll introduce you to my favorite triangle, maybe in existence. I don't know, definitely in the top 3. Let's just try one like this. So if I give you this and I said, hey, this side was 6 and this side was 10, and I asked you to find the hypotenuse, right? One thing that you know about this answer before we even begin is that that number for that's gonna, whatever I'm gonna figure out, this number has to be bigger than, Julia, not bigger than 16. It's actually gonna be less than 16. It's gonna be bigger than. Person. It's gotta be bigger than 10, right? Because isn't this the longest side of the triangle? So if these two sides are 6 and 10, this is supposed to be the biggest. It's gotta be something bigger than 10. Okay, so when I go to solve this, who goes in for C? Which of these 3 sides is C? the one that's marked X. A and B don't matter. So if you're gonna do Pythagorean theorem with this, I would do something like 6 squared plus 10 squared equals X squared, and then I just solve. I just do the math. 36 plus 100. So I just want the square root of 136. Whatever that simplifies to be.
Pythagorean theorem is a,
It sure is. So I could simplify that. 4 and 34 go in, so that would be 2 root 34. Okay, real quick, let's try another one. What if I told you this time that the hypotenuse was, let's make it 12.
you're lying.
Let's say this side was the square root of, oh, I don't know, how about 11? And I wanted you to find this side. Before you even start, what do you know about the value of X? Yes, it has to be less than 12, right? Because 12 is already the biggest side. So if you do this wrong, because I can't tell you how many times kids just put in the two numbers for A and B without even looking. They would get some value that's bigger than 12, and that doesn't make any sense. Because 12 is not A or B. 12 has to go in for C. You have to put 12 in for C. The legs don't matter. But if you put 12 in the wrong spot, you're going to get the wrong answer. All right, so now Pythagorean theorem, a squared plus b squared equals c squared, yada, yada, yada. Square root of 11 squared. B is the one I don't know. C is 12. What is the square root of 11 squared? Just 11. Bless you. Subtract the 11 over, what's that, 133, and then whatever the square root of 133 is. That's probably, it's 133 prime. Oh, 7 and 19 go in. But I don't think it has any perfect square factors, so I think I'm actually done with just square root of 133. Which, if I figured out what that is as a decimal, square root of 133 is 11.5, less than 12, right? Because I would want to make sure that my answer should be something less than 12, and it is. So if this were, like, here's a great example. If this were multiple choice, right? If there's any number bigger than 12, I'm immediately crossing it out. It can't possibly be right. 12 is already the biggest side of my triangle. All right, any hoosers, I told you I'd introduce you to one of my favorite triangles of all time. It's called the 3-4-5 triangle. The 3-4-5. Are you familiar?
No.
Ah, an old friend. 3-4-5.
See, I know that triangle because when I was in computer programming, and we made a program about one of the Pythagorean theorem. One of the things that she has tested is the triangle 3-4-5.
It's the best. Why is it the best? Because first of all, 3-4-5 is so easy, and it actually fits. 3 squared plus 4 squared truly does equal 5 squared. So if you are given a right triangle, and I said, hey, those two sides are 3 and 4, what's the length of the hypotenuse? You automatically know it's a 5. If I hit one of these and I said, hey, if the hypotenuse is 5 and one side is 3, what's the other one? It's automatically 4. So I know what you might be thinking. Okay, well, 3-4-5 works. Could I do like 5, 6, 7? No. No. If you try 5, 6, 7, 5 squared plus 6 squared is not 7 squared. So the only set of 3 consecutive numbers that fits a right triangle is 3-4-5. Consecutive numbers, 3-4-5. There are other ones that are nice, right? They're whole numbers. And that's what we refer to as Pythagorean triples. So Pythagorean triples are 3 whole numbers that satisfy Pythagorean theorem. So I'll just do a squared plus b squared equals c squared. There's lots of them, but my favorite one is 3-4-5 because it's so easy. There's other ones like 5, 12, 13. 5 squared plus 12 squared really does equal 13 squared. So they're very convenient to know, but there's no way you can memorize all of them. There's so many. But the 3, 4, 5, now it gets even better because not only 3, 4, 5 is a Pythagorean triple, all of its multiples work too. So if I give you a square and the 2 legs were like 6 and 8, that's just a 3, 4, 5 times 2, right? If it was 6 and 8, so then the hypotenuse would have to be 10. So if you'll start to see 3, 4, 5 triangles everywhere, right? So and you just keep seeing them. So then it just saves you from doing the work. You don't actually have to do the Pythagorean theorem out. You just see them, and then there they are. 3, 4, 5, boom, you know the answer without even doing it. Does that make sense? Do we love Pythagorean theorem? I knew you would. I knew you would. Okay, so I'm going to give you your assignment, and then I'm going to show you, I have 2 very important videos to show you. You'll be floored. Wait till you see, one of them is gonna really, you're gonna be surprised. All right, right triangles, here we are. Okay, let's do. Oh yes, I'll need the scissors back at some point. Okay, here is your assignment. Yes, you can recycle it. If you want to save it for forever, you can do that too. You can go home and hang it on your fridge. You could take the pieces and turn it into a festive tree and turn it into an ornament that you use year after year. Okay, so we're just doing multiples of 3 on these 2 pages. So go ahead and jot that down. I'll open that on Jupyter in just a moment.